Good morning, my dear students. Welcome back to the session. Today, we are going to see about the electrostatic shielding. Electrostatic shielding is the process of isolating a certain region of space from an external field. It is a process of isolating a certain region of space from an external field. That's why during a thunder accompanied by lightning, it is safer to be sit inside a car than in a open ground because of the metal body of the car provides electrostatic shielding where inside the electric field is zero, hence the electric discharge through the metal body of the car. This is the skill based question why it is safer to be sit inside a car or bus than standing under a tree because of the metal body of the car provides electrostatic shielding where inside the electric field is zero, the electric discharge through the metal body of the car. What called electrostatic shielding? It is the process of isolating a certain region of space from an external field. Therefore, the net electric field inside the conductor is zero. Our next topic is called dielectrics or insulator. A dielectric is a non-conducting material or an insulator is a non-conducting material. It has no free electron. The electrons in a dielectrics are bound within the atoms. For an example, ebonite, a glass rod, mica. A dielectric is made up of either polar or non-polar molecule. Our next topic is called electrostatic induction. Electrostatic induction is nothing but the induction of induced charges, charging without actual contact. Our next topic is called a non-polar molecule. A non-polar molecule is one in which the center of positive and negative charge coincide with each other. It has no permanent dipole moment. For an example, H2, O2, CO2. In the case of polar molecule, in which center of positive charge and center of negative charge do not coincide with each other. Sometimes they may ask what are the differences between the polar and non-polar molecule. In the case of polar molecule, center of positive and negative charges are coincide with each other. In the case of polar molecule, center of positive and negative charge do not coincide with each other. In the case of non-polar molecule, it has no permanent dipole moment. In the case of polar molecule, it has permanent dipole moment. So polar molecules are randomly oriented in the absence of electric field. Diagram number A represent which are in the random motion, random oriented manner. When these polar molecules is going to be placed in the field of electric field, external electric field. When an electric field is applied, the molecules partially align with the electric field. See the diagram. They oriented themselves with the help of the electric field. Our next topic is called polarization. It is defined as the total dipole moment per unit volume of the dielectric. For most dielectrics, the polarization P, which is directly proportional to the strength of the external electric field. Dipole moment P vector is directly proportional to E vector. Induced electric field inside the dielectric. In the case, we know that polar molecules are randomly oriented in the absence of an external electric field. When it is going to be placed in the field of external electric field, they aligned themselves with the help of the external electric field. At the same time, there must be an electric field is induced within the polar molecules which is with the help of the external electric field. This induced electric field phenomenon is called induced electric field. Our next topic is called dielectric breakdown. So when the external electric field is applied to a dielectric is very large, it tears the atoms apart so that the bound charges become free charges. Then the dielectric starts to conduct electricity. This is called dielectric breakdown. Dielectric strength. The maximum electric field the dielectric can withstand before it breaks down is called dielectric strength. For an example, mica 100 into 10 to the power of 6 volt per meter, Teflon 60 into 10 to the power of 6 volt per meter, paper 16 into 10 to the power of 6 volt per meter, air 3 into 10 to the power of 6 volt per meter, Pyrex glass 14 into 10 to the power of 6 volt per meter. This is called polar molecules, which we have studied already. In the polar molecules, the center of positive and negative charges are separated even in the absence of the external electric field. They have a permanent dipole moment. Due to the thermal motion, the direction of each dipole moment is oriented randomly. Hence, the net dipole moment is zero in the absence of an external electric field. For an example, H2O, N2O, HCl, NH3. We will see the remaining topics in our next class. Thank you.